Hello and welcome to yet another video of Cornerstones of Math. Today I have this nice little counting problem which can be considered quite easy if you know what to do, but also quite tricky if you cannot figure out what to do. So the problem says, for natural numbers n, let an be the number of strings created by choosing n letters from A, B, and C, allowing the repetition, also satisfying the following two rules. A, the same letters cannot appear consecutively. In B, the letter B cannot come immediately after the letter A. What is the value of A8? Alright, let's do this. And even though I can thoroughly list every possible string in an organized manner, I am not going to use such method here because we have to find A8. And 8 is not that small number, so we have too many strings to just bash through. So the smart way here is to find some kind of relation for our sequence an. So let us consider the string of length n, where n is sufficiently large. We can divide into three cases where the string starts with A, B, and C respectively. Let's call these cases 1, 2, and 3. Now it's time to think about the second letters in these strings. And this is where we have to consider these rules. In the first case, due to rule A, the letter A cannot appear in the second place. Also, due to rule B, which states that B cannot come right after A, the letter B is also forbidden. Therefore, the only possible letter that can come right after A is C. However, as for cases 2 and 3, rule B does not apply, hence the only rule we need to care about is A, forbidding the same consecutive letters. Therefore, after B, we can have either A or C, and after C, we can have either A or B. Let us name these cases case 2-1, 2-2, 3-1, and 3-2. So we are done with the second letter of the string, and let us consider the third letter. In case 1, we have C at the second place, so possible third letters are A and B. So the case is divided here as well, and let's call them cases 1-1 and 1-2 respectively. And then let us actually do one more thing on this case 2-1. It has A here. And we have learned that the only possible letter that can come right after A is C. So the third letter in case 2-1 is always fixed to C. And let us stop right here without proceeding any further, because we have just obtained an interesting result right here. If you look at cases 1-1, 1-2, and 2-1, there are A, B, and C in the third place, meaning that they consist of all possible cases for strings having length n-2. Therefore, there are total n-2 strings for cases 1-1, 1-2, and 2-1 combined. We don't know the exact numbers for individual cases, but they add up to n-2 in total. Similarly, if you look at cases 2-2, 3-1, and 3-2, there are A, B, and C in the second place, meaning that these are all possible cases for length n-1. Therefore, the number of strings for these three cases simply add up to n-1. Therefore, the number of strings of length n, an, is equal to these cases have n-2 strings, and these cases have n-1 strings. And this is our recurrence relation for sequence an. Once you reach this point, the rest is pretty easy. The only thing we need to be aware of is that this recurrence relation only works for n greater than or equal to 3, meaning that we have to find a1 and a2 separately. And you can easily find that a1 equals 3 and a2 equals 5. Therefore, a3 can be obtained by a1 plus a2, which is 3 plus 5, hence 8, and A4 can be obtained by A2 plus A3, which is 5 plus 8, hence 13. And you get the idea. So A5 is equal to 8 plus 13, which is 21. A6 equals 13 plus 21, hence 34. A7 equals 21 plus 34, which equals 55. And finally, A8 equals 34 plus 55, which is 89. And that was all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.